From flag planting to base building, why humanity is returning to the moon. In the annals of human endeavor, few moments are as monumental as July 20, 1969. Nearly 6 decades ago, against a backdrop of geopolitical rivalry and technological daring, Neil Armstrong and Buzz Aldrin stepped onto the desolate, silent plains of the moon. Apollo 11 was a triumph, a display of ingenuity that planted the American flag and collected invaluable samples, forever changing our perception of what was possible. But the excitement, fueled by the intense heat of the space race, eventually cooled. After the final Apollo mission in 1972, humanity turned its gaze earthward. The moon became a magnificent, distant memory. Today, that memory is being powerfully reignited. NASA's ambitious Artemis program is not a rerun of Apollo, it is the blueprint for a permanent off-world future. Poised to return humans to the lunar surface by 2027, Artemis marks a fundamental shift. We are no longer planning a brief visit, we are planning to stay. The Apollo missions were sprints, designed to win a race. The Artemis program, named for the twin sister of Apollo in Greek mythology, is a marathon designed to build infrastructure. This modern endeavor transcends the geopolitical showmanship of the past, focusing instead on long-term sustainability and technological maturation. The core goal of Artemis is not just to plant a new flag, but to construct a sustained human presence on and around the moon. This requires massive undertaking, including the Lunar Gateway. A critical component is the construction of a small space station orbiting the moon. This gateway will act as a staging area, habitat, and science laboratory for missions heading to the surface, significantly reducing the logistical burden of direct Earth-to-surface launches. Building a base. Unlike Apollo's temporary shelters, Artemis envisions the creation of a permanent lunar base, likely built near the moon's south pole. This base will provide living quarters, laboratories, and resource processing facilities, marking the first time humans have lived for extended periods on another celestial body. New technology development. The program is driving innovation in everything from deep space propulsion to compact life support systems and advanced spacesuits capable of handling the extreme lunar environment. The stepping stone strategy. Why the South Pole matters. The choice of the moon's south pole as the primary landing site is the key to Artemis's long-term sustainability plan. Geopolitical prestige aside, why invest immense resources in a permanent lunar base? The answer is simple: resources. Scientists have confirmed the presence of large reserves of water ice hidden in permanently shadowed craters at the lunar poles. This water is invaluable because it can be used for fundamental life support, drinking water, sanitation, and growing food. Crucially, water can also be broken down into its constituent parts, hydrogen and oxygen. Oxygen, breathable air for the lunar base. Hydrogen and oxygen, used together as powerful rocket propellant. This concept, known as in situ resource utilization, ISIU, is a game changer. If we can harvest and process propellant on the moon, it transforms the moon from a destination into a deep space gas station. The energy and cost required to launch supplies from the Earth's deep gravity well is astronomical. Launching from the moon, with its much weaker gravity, is exponentially easier and cheaper. Ultimately, the moon is not the final destination, it is the essential proving ground for the journey to Mars. A crewed mission to Mars involves challenges related to radiation shielding, closed-loop life support, and crew isolation that Artemis is specifically designed to address. The 3-day trip to the moon is manageable, the 6 to 9 month journey to Mars is profoundly challenging. By establishing a lunar base, NASA and its international partners can test critical technologies and operational procedures in a true deep space environment, outside of Earth's protective magnetic field, without committing the crew to a multi-year, non-returnable journey. The moon becomes the ultimate test bed for these Martian mission components. Testing how materials and humans react to deep space radiation, developing reliable, long-term, closed-loop resource recycling systems, practicing building habitats and infrastructure using local materials, regolith. The infrastructure we establish on the moon will serve as the essential launchpad, allowing future human crews to fuel their interplanetary vessels using lunar resources before embarking on the long voyage to the Red Planet. Nearly 6 decades ago, humanity took its first tentative step off-world. Today, with the Artemis program, we are preparing to take our next giant leap, one that involves tools, labs, and bases, not just flags and footprints. The return to the moon is more than just a nostalgic trip down memory lane. It is the vital precursor to human journeys to Mars and the foundation upon which humanity will build its permanent future among the stars. The new age of exploration is here, and it is built on lunar soil.